Question of the day. If this is the color of the engine oil.
Oh no, look at this.
And if this is the color of what I'm getting in the exhaust.
Look at this.
What is this? Doesn't seem to be diesel. Or if it is diesel, how is diesel ending up over here in such a big amount? This is my big question. This is going to be a different type of video. We are trying to diagnose a 2017 BMW X1. Smoke on the exhaust, a strange noise when the vehicle is stopping, and first observation is
Exhaust pipe has residue inside of it. Looking at it, it seems a combination of soot with some fresh oil. So if I actually clean it, I'm able to see oil and the normal soot.
engine bay looks a little bit dirty. Let's check fluid levels to see how we look and how the vehicle sits. Coolant to see if it is mixed with oil. Oil on a flat surface.
Oil inside looks to be clean. Doesn't look very dirty. Doesn't look bad. We don't see oil. It is the standard BMW color, which is the green type of fluid. We might be worried that the level is higher than normal, but we need to take into account that the vehicle is not parked right now on a flat surface. So I will come back and check that one. I'm just trying to understand why do we have this oily look on the components.
Smoke is not coming out because the engine is cold. I'm expecting it to burn the oil once it starts to get hotter. Vehicle is on a flat surface. We are checking level. The old-fashioned way.
So by the looks of it, it is on the low side now.
And we need to understand if that is confirmed, where the oil is going. But I'll give it a few more minutes. Maybe it still needs to come down a little bit. Are we able to remove the cover? Not much of a difference in access by the looks to actually see what is happening on the engine side. We need to start removing some of the trims to see what's happening underneath there. And also, I've noticed
If we look underneath, there is fresh oil on the exhaust pipe. Besides the oil or fluid that was in the pipe, there is something on the pipe. We need to investigate where it is coming from.
engine oil level after a few more minutes of waiting.
So by the looks of it, it's at the low point.
We will start taking things apart to understand why is the oil going out of the engine and try to build a better picture of what's happening with a battery power support unit connected to the vehicle so that we don't drain the battery. We go and we do the diagnostics. First, let's try the Mucar tool that I have for review. It's the 892BT. The aim of the game is to compare the DTC report from this one with the BMW ISTA to see if this type of tool is giving you the same level of detail and accuracy as the original BMW tool. Overall, we will be using the BMW stuff to make sense of what's happening with this vehicle. Ignition on. Battery support unit is connected, so absolutely no stress with regards to how much time we can spend doing our diagnosis. Also, on a vehicle that has issues with DPF or engine related things, it's not a good idea to keep the engine idling. So another reason for which a battery support unit is needed and is best practice. Diagnostics, I want BMW, and let's see what DTCs it's able to pick up. Until this point in time, I've noticed liquid, what I believe it's oil and soot on the exhaust, oily residue on the first part of the exhaust, engine bay that is misted, it has lots of oil everywhere, a low level of oil, so I'm not thinking of a regen that is failing and it's increasing or it's diluting the oil. Let's see on the DTC side what is happening. Also, I'm hearing a slight noise, maybe a chain immediately after you start the engine, and when you shut it down I hear 3 clicks, tick tack tack tack, something. Those seem to be strange things. We have some additional SOS failure and small little bits that we can sort out a bit later. Main issue will be understanding why we have the oily thing in the exhaust and what's the source of oil. I am going to create a report, and this report I will send it to my email address. Air mass, charger hose, leak detected, exhaust temperature sensor not plausible, exhaust gas temperature upstream of the DPF not plausible, air mass too high, throttle valve open to wide. An interesting selection of faults. I shall use the BMW tool, selecting the vehicle, and now we wait. A quick comparison. BMW software has identified 13 faults. These faults are, these are the ones. We need to compare them with what the diagnostic tool, that one, has seen. One of the interesting bits of information that we need to take in account, vehicle details, and might be useful. So, factory software was this one, 2017. Currently, it has a 2024 03535 software. This means that at a certain point in 2024, it had software update. Usually these software updates will happen in the dealership, and usually they happen if the vehicle has a problem, and I've noticed that many times when they are performing the EGR cooler and some emission related bits, that this thing is happening, which makes me think that in 24 month 03 the vehicle has had work done on it. We need to see, maybe something happened at that point. Also, we might be able to find some servicing history on a similar date with that. Let's try to make sense of some of the DTCs that we are having in front of us. Air mass leak detected, exhaust temperature sensor upstream of catalytic converter, something with the signal not being plausible, air mass too high, air mass too high compared to calculated, and all of these are happening at the same 735 mileage. After that, later we have temperature sensor short to something, short to ground, short to something, and in between that we have exhaust gas recirculation and throttle open to wide at the same mileage. And if we take a look, because on the dash we cannot see easily the mileage, we go to vehicle information. 193776 is the vehicle's mileage. So this happened not too long ago. Easy practice would be to clear all of these DTCs and see what is coming back. I'm also tempted of starting to take apart some of the things from the engine to ensure that everything is connected properly and understand the sources of the oil. So I might grab a picture with my phone of those DTCs and also start taking apart some of the stuff, because I need to understand, if I wouldn't have had the big amount of oil going everywhere, I would have just cleared the DTCs and seen which ones come back. But because I have the massive amount of oil, I actually want to make sure that everything is connected and everything looks as it should, or if not, see what's happening over there. Let's go and take things apart. So we are taking out many of the plastics and the trims to see what's happening. I'm also deciding of following the air, because we were having that air leak issue. Went to disconnect the coupler for the mass airflow. You see the big amount of oil that is over here. Let's continue with the process to see what else we find. Box. Come on. Whoops. It's busy. This is a very interesting bit. I've never seen such a thin oil coming out from that. Looky here. It's not oil. It smells like diesel. Or is it oil? Or is it diesel? Don't worry, we continue to investigate. Inside of air filter housing seems to be okay. Air duct seems to be clean and okay. Until now it's just strange, because we have a massive amount of oil or fuel in the connector itself. So we need to investigate what's happening over there. Let's see if anyone has actually changed the air filter. What do we have? We have a Kangst E1280L made in Poland. Do we have a date stamp on it? The filter doesn't look extremely bad, so let's give it a short. This will not be the closer. The problem is that the vehicle repairs. Placing the air filter back after cleaning it and inspecting it. No oil, no fuel in the air filter, just some liquid, either oil or fuel, in the sensor housing, not going inside. I'm looking at this engine and I'm struggling to understand what this is. Maybe it's a noise cancelling device. Doesn't look like a breather or something, so it kind of is restricting my access to see the engine itself. I'll try to remove it and see what we have, because after that this needs to go, that needs to go, for us to have a better view of what the engine is doing. So that one is not only 3 volts. So this is like an inertia. The air is able to swirl inside of it. Crazy solutions. Continuing to check for the oil and stuff. because this is on the intake side. No fluid inside of it. T30. Yes. Same here and same there. Whoop. These bolts are secured at the back with that. No. This is where the interesting bit is happening. So we have now access to the turbo and we see what's happening underneath. One of the common failure points on diesel vehicles is the turbo bearing. That is one of the areas where we have a feed of oil that can easily go on the intake of the vehicle. So we will evaluate if what we see there is backblow or oil from the turbo assembly. Let's take a look at the injectors. We'll remove this foamy bit, being mindful of all the connectors and the stuff that we have over here, because we will need to fit everything the same way. No residue over here. And when we look at the injectors themselves, relatively clean. Something is happening at this one by the looks of it. Maybe rocker cav or gasket or something, but not something excessive. This might be from when they've done the oil change and they dripped a little bit of oil next to the filler cap. Let's crack on and see what else we find. A little bit of spill on the sides, oil at the spark plug over there. But we need to understand how something fluid wise reached all the way in the coupler for the air mass sensor. Looking at the label of the EGR cooler, we can see that it is either made in 2020 or is made in 2024. So we need to understand that label 240120. That would make me think that this vehicle has had the EGR cooler replaced by the BMW dealership. That's also correlating with the fact that the vehicle has the software updated in 2024. I'm disconnecting another coupler that is part of the same harness to see if I'm getting the same amount of liquid, oil or diesel. I chose this one, and if we look at it, we have the same condition. We have fluid going in. Now, if we look at this assembly, we see a big connector going to the engine ECU. I want to disconnect this one to see if that fluid, oil, whatever it is, reached all the way to the ECU and see how it progresses from there. Good practice. I will disconnect the negative terminal of the battery and after that proceed in removing these two connectors and see what we get. Main ECU plug disconnected. We have oil or fuel, whatever that is, in the coupler. Same on this side. Because this is a different harness, I'm expecting to be able to have a comparison. So if we disconnect this one, take our time with it, this one should be clean. Yep, so we have a comparison between the ECU or a side of the ECU that doesn't have oil or fluid, whatever it is, and the one that is part of this harness. We continue to investigate where this might be coming from. Now let's try to understand where does the fluid come from. My next approach would be to go and look at other connectors that are part of the same harness. So we have seen that on this side we had fluid going all the way to the ECU, only in the connector that is on this harness. We will be checking everything that has to do with this to try to see the source of this oil or fluid. I was reading at a certain point something with regards to a pressure sensor somewhere at the DPF, but until we reach that one, let's go bit by bit to see what are the possible sources of this fluid. This one too has the beautiful oil inside of it. I'm going for the injector, and here we're seeing quite a lot of fluid. Maybe this is the source of our problems. Now, I want to do some research to see if injectors can fail in this matter, because just thinking of it, the injector having high pressure fuel, it would be able to send that fluid all over the place on the electrical harnesses and justify reaching all the way to the ECU. Injector next to the one also has fluid, and if you look at it, there is a gap which should stop a little bit the conductivity. This one also has it, and the last one, this one also has it. We need to understand what this fluid is. An even more interesting observation, if we look inside of the couplers for the injectors, look at the amount of fluid, and I really believe that based on the color, that is diesel that we have in the wrong places. Let's investigate to understand why would something like that happen. Now, the strange bit, based on BMW literature, many are saying that the source of the failure is the common rail pressure regulator, this one, and from here we get the fuel contamination. For me, it's strange that, let's imagine from here it goes there, but how would it be able to go through each wire to each injector and flood the injectors themselves? Okay, if we look and if we continue, so I've checked a coupler that was really far away, this one for the flap actuator, and it is contaminated too. Quite interesting to understand how the fuel reached over here. It reached all the way to this coupler, which might looks like glow plug control module. Continuing to diagnose this beautiful issue, something quite interesting, and I'm thinking, how is it outputting the fuel all the way in the exhaust? That is quite interesting. Based on the amount of liquid that we are getting, for sure, if it is reaching a sensor or something that is on this harness and has contact with the exhaust, it should also push it to the back of the vehicle. But let's investigate a little bit more. I've decided to go to the furthest point away from the source of our problem, which is the turbo variable valve actuator. And if we look at it, this one has diesel contamination also, something that starts to be quite worrying. I'm thinking, on this same wire we have some sensors after the DPF for regen. That would justify us getting liquid in the exhaust. To identify the correct source of our fuel, we will be reconnecting the stuff to start the engine. First, a lot of people are saying that there is a pressure sensor or temperature sensor on the low pressure side that can be faulty. We investigate that, and also we will try to see if something on the high pressure side is the reason for this. I'm thinking more of the high pressure side, but even so, until we reach that point, we need to clean. I've cleaned already the ECU coupler, some other couplers, and good practice, we get rid of the big amount of fuel that we have wherever we can do, to ensure that we are able to identify the source of the fuel. Painstakingly hard, but it needs to be done. We remove the fluid from the injector couplers. Removing it is more important than just blowing it everywhere. After test drive, the only coupler that has fluid residue is this one, the sensor for the high pressure fuel pump. This other one is clean, as clean can be. This makes me think that our root cause is fuel reaching this coupler, and after that contaminating the rest of the harness. At the same time, that strange noise and some other codes that we are getting can be actual components that are not working, also due to the amount of smoke that the vehicle is outputting. We still need to investigate also the mechanical bit and clean the couplers to better assess what's happening. I would say to clean it and go for an even longer drive to see if it's getting even worse. So EGR is making a strange noise, and there is some mention about the throttle actuator, so we need to investigate this and this little bit. Also checking the second part of our ramp, which is the fuel pressure. And looking at it, it seems clean. Tricky. Doesn't want to cooperate with me. Oop. Roll the boat gently down the stream. That's a very nasty boat to undo. The last one of its kind. So, what is holding me back? Massive coupler. Yep. And surprise, we have lots of oil on this one. Something that would explain the code that we are getting for this. What I'm believing that will happen when I take this thing apart, it will be full of diesel. This might be a temperature sensor by the looks of it, and the throttle. This one seems to be completely stuck. No, but it is stuck. Shouldn't be. Something strange is doesn't have any resistance. Oh no, it is not a Torx. It's something else. Eureka! It's a TS20. Let's see if it has diesel everywhere. We need to cut these tabs. But as a spoiler alert, we can see it on that it was full of diesel. Yes, this was the tool. No. So everything inside is full of diesel. Now let's understand what is happening. Look at this. So the mechanism, the wheel, is damaged, and we can see part of it over here. Also, based on the operation, it chewed a little bit from that side. Intake, swirl flaps, actuator, fuel, inside bubbly. Should be the same thing with the throttle body. Has an issue, so the actuator inside is flooded. Glow plug, control module, whatever else is connected to the harness, if it has contacts to it, more than likely is flooded. Once we take all of them out, we see how the vehicle behaves. I could not resist the temptation of investigating further the problems of the BMW, so I removed the under tray, and now we are looking at the exhaust of the turbo, which is dirty from a fluid, which at the first glance would be an indicator of maybe oil or something bad happening with the turbo. But I took the decision of following the air line, goes to the intercooler. At the second part of the intercooler over here, if it would be a big issue with the oil and with the turbo, we should have a lot of oil on the intake, and this is not the case. Furthermore, the thing gets a little bit more complicated, because if we look on the exhaust is dirty, but is dirty with something that is clean. So my assumption, my way of thinking, my evaluation is that this is not oil, but it is diesel. I will need to investigate and understand how we are getting it there in that amount, because on the top bit where the DPF is sitting, the things are relatively clean, and thinking that we are getting it out the fluid from this point, from that joint, let's see, from here to come out and spread until there is a little bit of a strange thing to consider. Not impossible, but yeah, it's a little bit strange because it starts from here and continues. Well, I'm gonna continue investigating. Also, out of curiosity, let's see if the sensor or if the coupler for the fuel level and quality sensor has also diesel inside of it. Push in, grab it to the sides. Up. Well, based on the amount, we have our answer. Or we now know the complexity of cleaning the harness on the vehicle. The amount of fuel is quite extensive. One more try. I'm also mindful of not polluting, so I'm placing something to catch the residue. Quite a serious amount. That's how the wire goes there. The starter motor. Based on how dirty the connector for the actuator of the turbo is, it is my belief that what we are seeing underneath on the turbo exhaust outlet is in fact fuel that is coming from here or from the bottom of the actuator and going on the plastic outer casing, because we do not have too much oil or any contamination inside the exhaust system. Main issue, fuel in the exhaust. We're looking at the last element after the engine. We have the DPF and we see a sensor, a pressure sensor at the middle of it, so it would be a end sensor, and at the same time we are able to see another sensor, which I believe is a oxygen sensor. I will be disconnecting the couplers to see if fuel is getting in through these ones. Looking at the pipe here, I believe that we have fuel coming in this line. At the same time, if the sensor reached the point where fuel was going from a nice bike is coming, if the sensor reached the point of fuel going through the coupler all the way out through the port where it should be monitoring pressure, I'm questioning the health of that sensor. But up to that point, we will first disconnect the piping to see if we're getting fuel inside. And these sensors, diesel fuel going into the DPF is not really that big of a issue because it shouldn't contaminate it completely. Fuel could burn. Oil would be a bigger issue. But yeah, let's disconnect and see what we get. Good news for this sensor. So this harness is completely dry. Nothing to worry about over here. At the same time, this harness might be part of a different harness altogether. On we go to this little beauty. The differential pressure sensor. What don't we do in the name of science? Whoop. I'm not as flexible as I used to be. So our access point for this sensor is here on top. If we look at it, it is somewhere over here. We might remove this just for having better access. If only I knew that before I climbed here. Second time lucky. Don't put all of your weight on the headlight. Up. Or on any plastic thing. Because this is not something that these things have been designed for. Pressure sensor is this one. This is the little baby. Those are the lines. I'll see how I am able to take them out. I've changed my mind. Rather than disconnecting the lower bit, I will be disconnecting only the top bit because it seems more accessible. And before we take it apart completely, I will clean it to ensure that we're able to see the diesel contamination and not the spray that I used to be able to remove it. This one seems to let's examine. In the name of science, we're looking at the differential pressure sensor for this BMW that had the contamination of the diesel fuel. We see diesel fuel in the coupler, but if we actually look on the inside, and I will show pictures with the inside a little bit better, but the insides are perfectly clean. So this is not the source of fuel going further down in the system, and also I will show pictures of the pipes. The pipes are perfectly clean, so fuel didn't get in the exhaust on this route. It managed to get there on a different path. The engine harness starts underneath with the sensor that we have previously looked at, and I should be able to pull it up. No, still has one more connector. As I was saying, the engine harness starts from this temperature sensor, oxygen sensor, clips to that thing, and later we go on top of the engine and see the rest. A few couplers disconnected, and we should be slowly able to take things apart. I will be disconnecting everything, cleaning the couplers, and trying to refit everything and see if the vehicle is able to work. This little one that goes to the AC compressor, by the looks of it, will be nasty because I don't have that much space to reach there. Protective cover of the battery removed. We will be moving also we will be looking at removing also the ECU to ensure there's no fluid inside of it. I've got out the ECU. Main connector is full of diesel. Second connector is okay-ish. Let's see if we just spill it like this, if it is anything. What I can see is that this little breather, this little bit, seems to have some fuel residue inside of it. Realistically, we cannot open it without heating it up and cutting the perma seal that is all around this unit. We will see if we actually need to do it. We will inspect the seating position of the ECU. So there aren't traces of diesel here. One more interesting coupler to note, which also has the diesel contamination, being this one that feeds into the other harness, the smaller, I would say, dashboard harness. But yeah, this one to check still. Let's take a look at the flap actuator and see how diesel, or if diesel, got inside of it. Try to see if we are able to save it a little bit. TS10 and the moment of truth. We're starting to see the quantity of fuel that is in this one. Still going. Filling in the microfiber. And still going. I will change my approach. And go straight in a container. Look at this. In other words, the unit was full of fuel. pay attention to what I'm doing over here. Inside, this becomes of concern to me, the amount of expansion that the seal is showing. I don't know if I'm able to refit it as it was. I might have to cut it. Still having fuel. So quite important to go in all of these actuators to remove the excess fuel. Assembly process, trimmed the gasket. Main wheel goes in. I'm applying some GT85 as a lubricant. And the top wheel assembly. Because the BMW is special, we need to go and find a vise and later a torque wrench to be able to fit that high pressure fuel sensor. Let's grab the vise. Beautiful vise in hand. Day 3 or 4 into the repair. I'm waiting for the high pressure fuel sensor to arrive, and I took the decision of removing the ECU, cleaned it a little bit and place it like this, with the hope that if it has fluid inside of it, it will start to drip out. At the same time, I placed it on a bit of cardboard to see the signs of progress. To speed up the things, I'm gonna place this one in direct sunlight. EU cardboard underneath to see the traces. It's hot even for me to hold it. And if we look in the couplers, we're starting to see the fluid coming out. Are we going to see fuel in this vacuum actuator? Because it's quite dirty. If I'm looking at it, sadly enough, I would be tempted to thinking that yes, the source would be this little one, and maybe we need to understand where else it is going to. It is dirty and it is really awkward to remove. Taking out the dinosaur. This little baby. Yeah, by the looks of it, both sides have. No, this one, the big one, is clean. So if we have it only in this one. But if I'm looking at the inside of it, it feels to be clean. Seems to be dirty on the inside. Let's make a bit more space. Let's see what is this one all about. Now we are going after the EGR actuator to check what is inside and if we have fuel to clean it up. I'm seeing these two bolts. We remove them and we see what happens. You can tell that something has been done on the EGR assembly because the clips or the sealing elements from BMW are these ones, and these ones look like aftermarket ones. Same story on this side now. Ta-da-dum. As I'm looking at this EGR, I'm tempted to thinking that a good source of fuel on the exhaust of the vehicle would have been if the EGR would allow fuel to drip here, because it has contact straight with the exhaust of the vehicle. But let's take it apart and see if we actually have fuel inside. Inspecting the markings on the part, this 23 over here, and on the cast, the 23 over here, makes me think that this is a 2024 part. So this has been replaced at the same time with the EGR cooler. It's not the original actuator that the vehicle had. This one is not that bad. It's just extremely dirty, but it's not full with fuel. So we still do not know the cause for our main problem. So the gasket is on the other part, and the failure point is that we are getting soot inside of this, mainly this seal. What is happening here is not sealing up the assembly completely. Am I able to take it out? Nah, they welded it. And we have a nice spring on the back. This is the same thing that you see in the exhaust of some cars. And inside of here, that magnetic surface should translate its position to let the ECU know how much it is open. So when this is too clogged up and it's not reading properly, you get a DTC. Back in place. We get ready the surface to place back the EGR. Time to go after the common rail. First, we mark the order of the pipe. Realistically, we cannot mess it up that much, but good practice says that we need to do it. Undo the nuts, undo the bolt, disconnect the stuff, and later remove this. Pipes. No. And I find it. Let's clean it. Just from a visual point of view, the construction seems to be a little bit different. Part number is the same. Now, torquing 70 Newton meters, but because I don't have a long enough socket for this one, I shall be using that adapter. And in theory, if I set this one at 70 and I have that extension, I will be torquing it at more than 70. So be mindful of that. Ideally, you should do the calculations, but I wouldn't believe that the difference is that big. because I'm offsetting it by this much here from there. So in theory we have reached 70. Back with it to the vehicle. After that, like that. After that, to the left, to the right. After that, get rid of this one. After that, try to align this one. And now in theory, put these bolts in. Oh. I do not want to risk damaging the return lines for the injectors, so I will be disconnecting them to allow me enough movement to torque correctly all of the bolts for the high pressure fuel lines. (24–25 Newton meters for all of them. Roughly, if you're in the area of 24 to 27, you're still okay. Now, theoretically, we should have been changing also these little gaskets. Let's start placing back bit by bit the things, because the turbo actuator was full of diesel and it had markings on, or some fluid was going down on the intake pipe. I will remove the actuator, and to do that I've seen two bolts on the back of it, but it's really hard for me to reach them. So first I'm gonna remove the shielding for the turbo and see if I'm able to reach it. I might have a better chance from underneath. And look at it now. So the key is to go from underneath. Easier to do when you don't have to film. And one last bolt over there. Ta-da! And the winner is... look at those two little beauties. That and that. I want to undo them so that I can remove and clean the turbo actuator. To get to the turbo variable actuator, you need to assume this nice little position, and you will see that with an extension you have just the right angle to undo the two bolts. And it looks like this. One leg on the battery, one on the metal frame, so that you do not damage other things. Be mindful not to damage sensors. First screw. And we're looking at the second one. It's coming out. Maybe grab the actuator so that it doesn't fall. Now let's see if I move it left and right. Do we have another bolt? By the feel of it, we might have, and it is underneath this lever at a very awkward angle. By the feel of it, need to be over there. Really nasty position. But in the name of science, this was the last one. Oh, it has a security washer by the way. How complicated can it be? By the looks of it, not that complicated. It's quite friendly. Oh yeah. The turbo actuator would be really easy to ignore it and not clean it because it has a very hard position to reach, but I did not give up, so just listen to it. Yep, I'm gonna unclip it and we see how much fuel we have inside of it. What should we use to remove these clips? We use this because if you look at them, they have that center tab that is meant to lock the stuff. Let's try to use something like this. So first, I know how we do it. First we unclip that safety, we bend it, and after that we will be able to take it out. So you see it? The safety clip. As long as it is pressed, it will be very easy to damage that clip, so undo it first. Quite a lot of force in these ones. Oh yeah. What do you think about this? Did we have a lot of fuel in this actuator? No. And if you look, it has one of those fancy, this way of monitoring position is a very fancy way. I've seen it previously in some AFS headlights for Volkswagen. Have a nice little motor over here, moves things. Really interesting design. I really hope that the part is not compromised by the fuel. It might be a bit more complicated to fix them, but I have the right tool, or I just know the tool for this. Don't forget to push in these tabs that we have undone previously. Back with it to the vehicle. We inspect it to make sure that it is clipped properly. And after that, 3 bolts for the actuator. Always the trickiest bit is not removing but putting things back together. It will be interesting how I'm gonna fit these ones to the actuator, but that is where the challenge lies. One is in place. Number 2 will be, and number 3. We progressed a fair bit. I didn't show all of the steps, but now we are fitting the throttle body to replace the one that was broken, and we are getting closer to starting the engine. Let's think a little bit outside of the box and try to tighten it up from underneath the vehicle, because from the top you really do not have enough space. Like magic, magic is in the air. This new plastic construction for the throttle body is something really interesting. Can easily be snapped if you tighten it too much. And for the connector is the same story. You want to connect it from underneath the car, because from the top it's a pain in the ass. I really question how I was able to undo it. Couplers and harnesses made by the devil himself. Let's not forget about this little one. By the book, by the book. Key takeaway: if these 2 bolts do not align, it most likely means that this bracket is not fitted properly, especially at the back side. So refit it, and only after that attempt to put these 2 bolts back. Let's see now. Are they aligning? So still they're not wanting to play ball. Need to readjust it a bit more. Also, there is a channel here that it's quite stubborn. Now, perfect alignment. I didn't tighten up the positive terminal, so that goes out again. This is the special channel. This edge needs to slide precisely in that one. If not, it doesn't align on the bolt. Don't forget about grease on the lower bolt for the under tray. If you use it, these bolts will live forever. Little bit of grease never hurt nobody. Little bit of grease never hurt nobody. Hurt nobody. Peace. Let's also take a look at the mass airflow sensor to see if it has diesel inside of it. Looks okay. Looks like it has managed to survive. Up to the point of the owner replacing this part, I'm gonna do a repair exactly like the previous repairer has done, with electrical tape. Anyways, these ones get really brittle and it's acceptable to see them snap. Saying that, if we look at this one, it has been changed in 2024 based on the stamp. Due to the temperature and pressure, this is not the proper fix. And you don't even know that it's a bodge job. Look, so yeah, we give it a bit of power. And now we need to prime the fuel system. I will usually do it twice with a diagnostic tool. Now I'm testing the Mucar 892BT. Should be similar with the King Bolin and somehow similar with the launch tools. For this process to work, we need to have at least 20 liters of fuel. I've already checked and I'm having half a tank, which is really good, because it translates to possibly being able to start the vehicle. I'm hearing the sound from one of the fuel pumps. 120 seconds. Okay, let's do it one more time. Let's see how long it takes for it to start. Immediately after the first restart is good practice not to rev the engine, because many of the things are not calibrated just yet. Maybe you forgot something in the engine bay, or maybe something isn't as it should. So starting to do the instinctual thing of revving the engine is not really a good idea. We will do again a scan to see if the vehicle has noticed something. Health report. That one, I'm expecting it to be an issue due to our initial starting process. Exhaust temperature sensor upstream of diesel particulate. Some issues we will need to investigate. Maybe they are damaged. The physical repair is done. Now we're taking the vehicle on a test drive to induce a few heat cycles into the high pressure fuel ramp and all the other stuff to see if we're getting any leaks with that high pressure fuel sensor. I will go and check and potentially have to retighten some of the high pressure fuel lines. Till now it has never happened, but we need to be mindful of that. I'm also running a diagnostic scan. When I've used this little thing, I was trying to understand what is the situation with the DPF, and strangely enough I was seeing 0 grams of soot in the system, and I want to validate and make sure that this car doesn't have any dodgy remap or something done to it, so that it doesn't pick up the DPF. It might have other small issues like seals, rubbers, but we first want to stabilize the patient, get rid of the big concerns, and after that build the story and investigate further. Maybe potentially run a DPF test with the ISTA software, in which it is comparing the pressures versus what BMW has as a reference. Also, strangely enough, when I check the history, apparently the last regen happened 3,000 miles ago. So that also brings some questions about what has happened in the meantime. But let's see outside what is happening on the exhaust side of things. The exhaust seems to have become more friendly. And also realistically, immediately after doing extensive work on the engine, you don't want to wreck the vehicle, or you don't want to do extreme things, because it's human nature. Maybe you forgot something, maybe something isn't right. There's no point in chancing or destroying a vehicle just because you're in a rush. Question of the day: if this is the color of the engine oil, and if this is the color of what I'm getting in the exhaust, what is this? Doesn't seem to be diesel. Or if it is diesel, how is diesel ending up over here in such a big amount? Where is it coming from? This is my big question. All that level of smoke and no DTC. Can you believe that? These are the codes. Everybody seems to be happy. Nothing major. These little babies. These things are allowing you to have access to these types of sensors without damaging them. And if you go for a quality brand like Brit tool, you are ensuring that they will be strong enough not to flex and actually help you take things apart. This is the temperature sensor before the catalytic converter. Let's also remove the oxygen sensor to see if we're able to see better inside. No. Oxygen sensor. And now with an endoscope camera, I am trying to see what's happening. Intensity to the maximum. Let's see what we have inside. Is that fluid? Looks like it. Haha. This is an interesting thing. So we have a big quantity of fluid accumulated. And I'm able to notice it, or I'm confirming it, because I'm shaking the vehicle. Again, the strange behavior. This is the fluid that is in the exhaust. Perfectly clean. Doesn't smell like diesel, smells like oil. But it cannot be oil because oil in the engine should be dirty. Here you go, the comparison. Engine oil and what we're getting on the exhaust. Different color altogether. The old ECU got cloned to a better old ECU. This one should be healthier. We take it to the car and we see what DTCs it's able to see. Cloned ECU is in. These are the codes that the vehicle is seeing. By the looks of it, the codes have disappeared, or previously they were with a different state. We might have done a good thing by replacing the ECU, and maybe the ECU was the cause of our problems. It's a miracle. No DTCs. Let's see if the vehicle starts. Like a charm. And now let's reread the codes. Also, I will want to flash this ECU to the standard map to make sure that it hasn't any dodgy business happening inside of it. I found a way of forcing engine ECU reflash. Looks like it is starting. Strange noises are coming out from the engine and fuel pump. Main source of sound is the fuel tank. Power usage 21 amps at 13.5 volts. All sorts of strange sounds coming from the engine area also. We're starting to see progress with regards to the software deployment. The most important OK that you need to click. The question becomes, will it start? Started fine. Sadly, I reached the moment where there's nothing wrong electrically with the vehicle. We have some sensors that are reading strange values, but nothing to explain the heavy smoke and any fluid coming from the exhaust. And sadly, I kind of need to give up and send it to someone else to look at turbos, EGRs, more expensive mechanical things to consider. If I have the opportunity, I will touch base and see what was actually the main fault. But we reached the end of what we can do with the tools and space that we have available.